morning to our power buddies. Today our topic is about chapter 3. So in chapter 3, we are talking about electric current and direct current circuit. We are one group consists of 4 power leaders. My name is Kumpulan, and beside me is LING, and she is CELINE, and you are CHIA. So in this chapter we have 9 subtopics, and the first one is electric current and direct current circuit, and the 3.2 is Ohm's law and resistivity, and the 3.3 is variation of resistance with temperature, and 3.4 is electromotive force, internal resistance and potential difference, and the 3.5 is resistance in series and parallel, and the 3.6 is Kirchhoff's rule, 3.7 is electric current and electric energy and power, and 3.8 is potential divider, and 3.9 is potentiometer. Today we are talking about only two subtopics, which is the first one is 3.6 Kirchhoff's rule and 3.9 potentiometer, because they are the most frequent occur in the exam paper. So we are put our focus on 2 subtopics. So I like Celine to take over.
So now I'm going to explain about subtopic 3.6 Kirchhoff rule. Alright, what is Kirchhoff rule, and when we need to use this Kirchhoff rule? We use this Kirchhoff rule when they contain a complex circuit. And what is complex circuit? The complex circuit when they contain more than one battery. So the Kirchhoff rule contains 2 laws. The first is the Kirchhoff first law and the Kirchhoff second law. The Kirchhoff first law is also called as the junction rule, and for the Kirchhoff second law is can also called as the loop laws. So for the Kirchhoff first law, it is all about the current, and for the Kirchhoff second law, it's all about the voltage. So now I will explain about the Kirchhoff first law first. So the formula for the Kirchhoff first law will be the summation of current flow into the junction equal to the summation of current flow out of the junction. And this formula actually is obey the conservation of energy, electric charge, because from the formula of current, it is the I will be equal to the delta Q over the delta T. So we can know that the current actually is the charge. So this formula actually is obey the conservation of electric charge. So now we proceed to this simple circuit, and we can see that they contain 2 junctions, which is junction A and also the junction B. So we look at the junction A first. Where is the current flow into the junction A? And we can see that the I1 and also the I2 is the current that flow into this junction A. And the current flowing out the junction A will be the I3. So how can we construct the equation at this junction A will be the current flowing in I1 plus the next current flowing in the junction A I2 equal to the current flowing out. So this will be the first equation for this junction A. And same as the junction B, the current flowing in will be I3 and current flowing out will be I1 and I2. So the equation for this junction B will be I3 equal to I1 plus I2. So when you're solving a problem, you just need to choose any one of these equations. You can whether using this equation or this equation, and at the end you will get the same answer. So now I will explain the Kirchhoff's second law. And the equation for the Kirchhoff's second law is the summation of EMF equal to the summation of IR. And this formula actually is obey the law of conservation of energy. This EMF, and also this IR, both of these are the voltage. Why this IR is voltage? Because from the formula V equal to IR, the voltage can be read as the voltage of external resistance equal to IR, and also the voltage of internal resistance equal to I smaller r. And this formula actually is come from the original formula, which is EMF equal to IR plus I smaller r. And when you compare these two equations, actually they both are the same. This will be same as this, and this IR plus I small r equal to this IR. So we can know that in this IR in here, actually it is include the external resistor and also the internal resistor. So, and the voltage difference between this EMF and this IR is, this EMF is the voltage supplied by the battery, and this IR, the voltage here is the voltage have been using up by the resistor. So now we proceed to how to determine the direction of EMF and also the sign. So now we can see this battery. We focus on battery first. At this, the first thing you need to do is you need to label the terminal negative and also the terminal positive of the battery. Then you need to label the direction of EMF. The direction of EMF is always flowing from the negative terminal to the positive terminal. And then how do you determine the direction of EMF is when if the direction of loop same with the direction of EMF, the sign of the EMF will be the positive. But if the direction of loop is opposite the direction of EMF, the sign of EMF will be the negative. Alright? So now we proceed to the resistor. How do we determine the IR, the sign of IR? The first thing that you need to do is you need to label where is the current flowing. From this diagram, we can see that the current is flowing to the right, and the direction of the current actually is same as the direction of loop. So the sign of the IR will be the positive. And same thing as if the direction of loop is opposite the direction of current, the sign of IR will be the negative. So from these two, we can summarize as if they both are in the same direction, the sign will be the positive. If both directions are in opposite, the sign will be the negative. So that's all from me. The summary of some topic 3.6 Kirchhoff. Now I will pass to next part leader TIAN to giving you some example in problem solving.
Hi everyone, from the last question, it has two loops. So for this circuit, it's different from the circuit we usually see. So we can now draw a new circuit, follow what circuit that we usually see, so it's easier for us to solve the question. So as shown here, this is the R resistor 1, which is 12 ohm. Therefore, the current flow at this circuit is I1. And then the second resistor is 18 ohm. Therefore, the I2 is at here, is at different direction, is opposite direction, I2. And the second one, and the third one is resistor is 8 ohm. Therefore, is 8. We label the I3. As you can see here, it has two loops, therefore it will have junction. So now we are going to follow two laws, the first law and the second law, junction law and the loop law. So we just use the first law, junction law. The total current in will be equal to the total current out. So as you can see here, it has I3, I2, I1. We can say I1 will be equal to I2 plus I3. This is the first equation. And we can write it here, I1 minus I2 minus I3 will be equal to 0. So now we are going to look at the second law, the loop law. We start with the first, with current one, the first. We can choose two loops. So now I will choose this loop and this loop. And the same, we have to label the direction of the loop first. I will choose the anti-clockwise. I label the first step. The total EMF will be equal to the total IR. Therefore, the first EMF is 6 watt. 6 watt, the direction is from negative to positive, and it's same direction with the loop. Therefore, it will be a positive sign. Positive EMF 1. I label it as EMF 1, and the 9 watt will be an EMF 2. In this loop, we have only one EMF, therefore it only have 6 watt at here. And now we are going to look at the resistor. The direction of the current is to the right, and the direction of the loop is to the right too. Therefore, it will be a positive I1 times resistance 1. And we have the second resistor at here. The direction of the current is I2 and is to the left, and the direction of the loop is to the left too. Therefore, it will be a positive value I2 times R2. So we simply substitute the answer the value into it. 12I1 plus 18I2 will be equal to 6. This is the second equation that we get. Now we are going to form the last equation. I use the upper loop at here. The same step will be used. The total EMF will be equal to the total IR. At this loop, we only have one battery. It has only one EMF value, which is E2. So the direction of the battery is from negative to positive. So it's to the right. And the direction of the current, and the direction of the loop is to the left. They are both in opposite direction, so we are going to put a negative sign in front. Negative EMF 2 will be equals to, now we are going to look at the resistor, the R3. The resistor, the current flow I3 is to the left, and the direction of the loop is to the left too. It will be a positive value, I3 times R3, plus the second resistor in this loop is R2, and the direction of the current is to the left, direction of the loop is to the right. Therefore, we are going to put a negative sign because they are in opposite direction. So negative I2 times R2. And now we are going to substitute the value into it. Negative 9 watt will be equals to I3, R3 is 8 ohm, plus negative I2 times R2 is 18. So negative 18 I2 will plus 8 I3 equals to negative 9. So now we have formed three equations. The first equation, second, and the third. We can use calculator as simultaneous equation to solve this question. And then the final answer, you can get the answer from the calculator. So we have discussed this question, and now I will pass to CHIA to discuss the next subtopic.
Okay, so now we are going to look at 3.9. 3.9 is called potentiometer. So in this subtopic, potentiometer, we have 5 parts to look about. The first part, we will first know about what is potentiometer, this one, and then we will have to look about the functions of the potentiometer. Then we will look into the structure of what is potentiometer. Then the fourth part is tips. What is tips? Later on you guys will know, so please don't skip the video. Then last part, I will pass this to GUAN to discuss about some of the questions to let you guys have know more how to use the concept of potentiometer to proceed the functions of it. Okay, so without further ado, we will look at the first part. You guys can have a guess first. What is potentiometer? Here got a meter. We got what else of meter? Thermometers, right? So
thermometer is used to measure the temperatures, right? So potentiometer is same kind. We use to measure the potential difference. But di situ ada sikit tak sama lah. Nanti kita akan tengok. Okay, so first of all we look at the potentiometer. This actually is a potentiometer. The structure of potentiometer. So the potentiometer, just now I have mentioned, right, is used to measure the potential difference. The potential difference. But you guys can see I write to measure the unknown EMF. Okay? So what is the difference between EMF and the voltage? This is actually in the part of 3.4, electromotive force and also the difference between these two. So I give you an example. Here I draw a circuit. You guys can see here is a circuit, and here got a battery, here got a resistor. I want to change the color first, but I don't know how to use. Never mind. Okay. Never mind. I can use the same color. So across this battery there is EMF, and across this resistor there is potential difference. EMF basically is the power supply. The energy provided by the power supply to move 1 coulomb of charge. 1 coulomb of charge of the electron to move through the external resistor and also the internal resistor inside the battery. However, the potential difference across this resistor, we call it as V, is the energy, is the work done to move the 1 coulomb of charge through this external circuit, external resistor only. So there is the difference between the EMF and also the potential difference. So this potentiometer, we use this potentiometer to measure the unknown EMF of a cell. So why is it unknown? Later on you will know when we look at the whole structure of the potentiometer. But first, now we have to look at the function. And then, this potentiometer can also be used to measure the internal resistor of a cell. Just now I have mentioned, right, inside the battery, here got internal resistor. This internal resistor is due to what? It's due to the chemical inside the batteries, right? Okay, so this is the basic structure, a basic overview for potentiometer. So now, we have to look at the circuit of the potentiometer. Maybe you guys might not be familiar with this structure, but you guys might be familiar with the circuit of this potentiometer. Actually, the structure of potentiometer is basically made up of two circuits. Okay? Primary circuit and also secondary circuit. We have to know about the component inside the primary circuit and also the secondary circuit first before we apply the concept of potentiometer. Okay, so first of all, primary circuit is here. Okay, we got a battery. Normally we will call it as power supply lah. Here, this power supply, we know about the EMF of this power supply, and then you guys should realize here is a wire called PQ. You guys should know this, right? Okay? And we should know about the length of this wire PQ. This is the primary circuit, a simple circuit. And then there is a secondary circuit here. Okay? This one. You guys can look here. Here is also a battery, but we don't know. We don't know about the EMF here. So equal to a question mark. We don't know about the EMF of this battery. Okay, so just now I have mentioned, right, the functions of potentiometer is to measure the unknown EMF. Yeah, so we can use this potentiometer to find the unknown EMF of this battery. Okay, you guys can imagine here is a circuit. A circuit will consist of two ends, right? One end here, one end here. Okay. So you guys can imagine here the one end is connected to the point P, and the another ends of the circuit of the wire is connected to galvanometer. What is galvanometer? Galvanometer is used to measure the what? Who knows? Galvanometer is used to measure the currents. Yeah, the currents. Okay. It's used to measure the currents. Okay. So I just mentioned this first. Later on, you will know why we should have this galvanometer at here. And then this end is then connected to. And here is some messy. Is then connected to the point X. But here is a bit different. You guys can see here is an arrow. This means that this point is not fixed to the point X, but we can slide. We can slide it to here or wherever you want, here or here. Okay? So this is the basic structure of a potentiometer. Just now we have learned about what is this and the function and also the structure. Then we move on to the fourth part, the last two parts. What is this? Actually is how can we apply this potentiometer, the working principle of this potentiometer. Just now we said, right, the functions of the potentiometer is to measure the unknown EMF of a cell. Which cell? Cell is namely a battery, this cell. We don't know about the EMF of this cell and then we want to calculate it. This is the basic overview lah. So first of all, you should know about the EMF value of the power supply. This one, okay, we have. Then the second thing is you should know about the length of PQ. Where is the PQ? Here. The length of this PQ. And then after we know about these two things, we will slide the S. Just now I've mentioned, right? Actually, this is called jockey. Okay? We will slide this jockey until galvanometer equal to 0. The reading of galvanometer equal to 0. When galvanometer equal to 0 means that the current flow is also equal to zeros, right? So this means that there is no current flow through this circuit. Okay, so when we get the readings equal to 0, we will stop sliding it. And the length here will be known as balance length. Then, after knowing all of this information, we can use the information to calculate the unknown EMF or something disappeared. Okay, so we will use this formula. V divided by L equal to V divided by L. This means the EMF of power supply, you know, right? And the length of PQ we also know, equal to the unknown EMF of the cell divided by the balance length. Okay, we have this, and then we can calculate this. This is the basic, the working principle of this potentiometer. Okay, you guys might curious about why we should slide the jockey until galvanometer equal to 0. When galvanometer equal to 0 means no current flow through this circuit. Then why no current flow through can calculate the unknown EMF? This is because we know the current is equal to Q divided by T, right? The flow of the charge. So when will the charge flow? The charge will flow when there is potential difference between 2 points. You guys can imagine can symbolize this like a bottle of water. When there is a difference in the gradient, then the water will flow. This is the same case as the charge flow. So when there is potential difference, then the charge will flow. When the charge flow, and then current will be produced. So when no current, when galvanometer readings appears to be 0, this means that there is no potential difference between this point and this one. So we can use the formula here to calculate to get the EMF of this cell. Okay, so this is the basic overview of potentiometer. Here is the structure, this is the function to measure the unknown EMF, to measure the internal resistance. This is the structure, primary, secondary, okay, unknown EMF, known EMF, this length, and also this balance length. Okay, and this is the overview. Okay. Later on, I will pass to GUAN to discuss about some of the questions to make you guys know more about this potentiometer.
Okay, thank you for testing about on the explanation of potentiometer. So I will show two example of question to let you realize what the question is asking about. So let's start with question 1. Okay, here is my question. Well, in this circuit, we have, like Chinese say, we have primary and secondary circuit. So the information we provided is there is a 3 volt in the primary circuit for the battery we know, and there is a resistor here, and when the jotter is set at X, the reading of galvanometer shows no deflection. What means no deflection? That means there is no reading, it means it is at 0. So when it is set at X, the distance between X and P is 60 cm, and here's something that will be complicated, and we will have to draw a table later on. So the first question is, by neglecting the internal resistance of the 2.0 volt battery, calculate the EMF of battery B. So we will not don't have to care about the internal resistance of this battery, but we have to find this EMF by comparing this primary and secondary circuit. So I will show my answer on my paper. So can you guys see clearly? Alright. So I have drawn again my circuit, and I have turned out that show no deflection means 0 volt. And here we have to use one formula, no, 2, because we will compare 2 things at this question. So first is V equals to IR, and V also equals to I times PL over A. The P is the resistance, the constant of the material that you use to use with this wire, but we do not use this at here, and also the area, because we will only compare VR and the length. So I have said right at here, V is directly proportional to R, and also V is directly proportional to L. So first step is we have to draw a table. So the first column I write is 2.0 volt, which is here. Then why I put 1.5 plus 2.4 equals to 3.9 is because P to Q, the total resistance is 2.4. So why I write the same thing here is 2.4. This is for voltage PQ, which is at here and here. And the 1.5 is come from here. So this is the primary circuit. You only look about, you only know about the primary only, so you don't have to care is there any resistance or anything happen to the secondary circuit. So in here we have this is one resistance, because this wire has a resistance which is 2.4, and one here is 1.5. So we can assume it as we got 2 resistors in this circuit. Then we write down the information. The L is not important, because the first thing we will compare is V and R. So the second thing is we write VPQ, and 2.4 is for this resistance from P to Q. So that's one only, 2.4. And the length is 100 centimeter, which has shown on the question. And the last thing is the electromotive force of B here. We don't know about the information of this, so we just leave it like this. And the R, in this secondary circuit, do you see any R here? If you see, yeah, is one. From here to here is the resistance, but we will not use it because we are comparing the second question, the electromotive force of B with the length. So we just leave it blank like this. So we don't use this information. So the second step is to find the voltage of PQ, which is here to here. Then we apply the ratio V equals to ratio of R. So V PQRS equals to V PQRS divided by R PQRS is equal to V PQ and the R PQ. So first, V PQRS is where? This is the V PQRS, which is PQRS. So the voltage in there is 2 volt, and the total resistance is 2.9, and so start from here. And here, BPQ we don't know, so we leave it like this. And for RPQ, we know that it's 2.4 only. So by we move 2.4 to here, and we got BPQ is equals to 1.23 volt. So from there we can compare the next thing, which is electromotive force of Px. So first we apply ratio B equals to ratio L. So 1.23 is coming where? 1.23 is voltage of PQ just now. Then the length is 100 here. And we don't know about the electromotive force of Px, which is for B. So we leave like this, but we know the length. 60 centimeter. And by substitute it, by move it, we can get the electromotive force of Px is equals to 0.738 volt. For this question, can you understand how to do it by step? Or do you have any question about this? No. And this is the end of our discussion. Thank you.